Okay, look at this one. Now this question. Using the substitution x equal to cos 2 theta, show that the integration of this with the limit 0, 1, you get pi upon 2 plus 1. Okay, so we are going to show this. Of course, this one, we cannot use the first method. You cannot use the first method like this. You can check, cannot. And then partial fraction also cannot. This is a fraction, but how are you going to factorize? Cannot. So only way is substitution. And then how to know whether to substitute this one? Actually, you don't need to know. Okay, this is given. You just follow. So now you are asked to substitute x equal to cos 2 theta. Okay, so then you differentiate, because I need to substitute this one as well. So I differentiate dx d theta. I get differentiate cos. I get negative sine 2 theta. Then differentiate the sine. Is it? Then I will get this. You know, when I want to differentiate cos 2 theta, I differentiate the cos is negative sine 2 theta. Then differentiate the 2 theta, I get 2. That is why I get this. And then therefore dx, I'm going to substitute the dx here is this one. So dx will change to this later. And then because you are asked to substitute x equal to cos theta, now I want to change the limit as well. When x, this is x, when x equal to 0, when x equal to 0, I substitute x equal to 0, cos 2 theta equal to 0, 2 theta equal to pi upon 2, 90 degree, and then the theta is pi upon 4. And then when x equal to 1, this is x equal to 1, I want to change to theta, so cos 2 theta is 1, then cos 2 theta is 0, because cos 0 is 1, then theta is 0. So I just substitute here, you see, when theta equal to x equal to 0 is pi upon 4, you see, pi upon 4 at the bottom. You must follow, x equal to 0, theta is pi upon 4. X equal to 1, theta is 0. You don't, I didn't say this is smaller, this is bigger. No, remember that. And then this one I just change. I substitute cos 2 theta, the x. I substitute. And then the dx also I change to this, negative 2 sine 2 theta d theta. Actually it's continuous because I got not enough space here. Okay, so this is what I get. Then what I do here, I use the identity to simplify this. Because I know cos 2 theta can be written like this. 2 cos square theta minus 1 or 1 minus 2 sine square theta. I have these two. So you see the top one, I choose this one. 2 cos square theta minus 1. Why? Because I choose like this so that after the 1 and the 1 I can cancel. Easier. That is why I choose the suitable one. And then here 1 minus cos 2 theta, now I change, I choose this one. Why? Because if I change this one, 1 and 1 can cancel. That is how we choose. Okay? And then this one will be the same, negative 2 sine 2 theta. So the purpose, I change this for the numerator, and the denominator I change this because they can cancel off the 1. Okay? So after I simplify, I get this. Okay, this is already, you get this. Then after that, this is 2 and 2 can cancel. You can cancel the 2 and the 2. And then cos square, you get cos theta, sine theta, negative 2, this one, you get this. And then after that, the sine theta and the sine theta also can cancel. Finally, you get this. Negative 4, I bring it up. Okay, then I get cos square theta. So how to integrate cos square theta? This is, we are going to learn this of course later, but now I just explain to you. You should be able to understand also. You see here, for this is of course you look at trigonometry, don't look at this, you want to integrate this. You see I have sine bracket, I have cos, but I don't have cos square, isn't it? But now I want to integrate the cos square. I don't have, I have secant square, I have cosecant square, but I don't have the cos square. I have only cos and I have sine. So how to integrate the cos square? We use identity. That's why trigonometry, why the identity is so important. You see the cos square, I can use this identity. So the cos square I can change to cos 2 theta plus 1 over 2. So once I change like this, you see from square I change to cos already. no more square. So afterward I can integrate using this, no more square. That is the purpose of using identity. Repeat, I repeat, here got cos square, but the list here we don't have cos square, we have only cos. So how to change? We can change the cos square using this identity. Cos square theta is cos 2 theta plus 1, you just shift here. Then you see this one already become cos. That means now you can use this one already, cos. Okay, now from cos square, which is not here, we can change to cos. Okay, huh? So you just write there, I write cos 2 theta plus 1 over 2, and then the 2 I bring it out, I can cancel here. That's why I get negative 2, then cos 2 theta plus 1. Okay, then afterward the cos 2 theta, you see cos, I can use this one already. I can use this. So you see I separate now, I show you negative 2, I integrate this one, and then the negative 2 with this one, 1. So when I integrate cos 2 theta, okay, now the bracket is here. The bracket is here. Follow this, the bracket. The bracket is here, the cos will become sine. So you see the cos will become sine, isn't it? Cos will become sine. And then the 2 theta you have to differentiate. You see you must have a 2 here, and then you divide by 2. That's why I get negative 1. Then the cos becomes sine 2 theta. Then 0 to pi upon 4. And then minus 2. And then when you want to integrate 1 here, because theta is theta. So 0 pi upon 4. Then after that you just substitute. Okay, you substitute 0, you get negative. Then sine 0 is 0. Sine pi upon 4 substitute become pi upon 2 is minus 1. Okay, when you substitute this one, you have to minus. Then minus 2, then 0, then substitute this one minus, then you get this. Okay, so okay, this part, you see how to integrate this. That means this part from square, you change to no square. How to change? Using the identity, as I show you. So if later you see sine square, later if you see sine square, you use this one. Also you see, no more, become cos. Okay, and actually tangent square also not appear here. We don't have it here, tangent square. So tangent square also not here, not in the list here, you see. Tangent square also not here. But tangent square, this identity can change to secant square theta. Then secant square already can integrate to tangent. Yes or no? That is how you change using the identity. Okay, so you just go through.